My name is Anvesh Gadam. I'm working as an advanced research engineering at Manufacturing Technology Center, UK. In this workshop, my presentation is about case study developments, as you can see in this slide. Today I'll talk briefly about Syntex case studies and then deep dive into each of the case studies, which is like automotive, medical, and thermal management. And finally, I conclude my presentation with the achievements what we have uh, uh, in this particular Syntex project. As Christoph mentioned, one of the aims of the Syntex project is to demonstrate real-world applicability of the hierarchical laser texturing. In this project, we have selected three particular case studies from different industrial sectors, seeking functional requirements ranging from pressure drop to heat transfer and antimicrobial properties in order to validate these approaches with sustainable digital green laser texturing approach. So in this table, as you can see, three case studies are shown. So the first case study is basically a injection molding tool. The end user for this particular case study is Fabless, which is from Turkey, and also Stellantis from France. This particular injection molding tool is belonging to the automotive sector, and in the Syntex project, three different functionalities are sought from the hierarchical laser texturing, which are shown here. The first one is pressure drop and antimicrobial and anti-scratch functionalities. And by achieving this particular functionalities, it is expected that we can reduce the injection molding pressure and reduce the energy and cycle time in injection molding process using the hierarchical laser texturing. And the second use case is hip implant surface. The end user is DP Synthesis from Ireland, and this belongs to the biomedical domain. And functionalities what we sought are to simply reduce the number of processing steps in preparing the hip implant surface. So simply it is called process simplification. And other two functionalities are related to adhesion and biocompatibility. And by achieving these particular functionalities, it is expected to improve the patient outcomes who have this hip implants installed in the surface. And the final use case is vapor chamber. The end user in this particular case is European Thermodynamics, and it belongs to thermal management sector. And the key functionalities which are sought in this particular use case are capillarity and heat transfer. And by achieving these functionalities, it is expected to cool graphics cards and achieve higher device efficiency by cooling the graphics cards in the real-time application. I will explain these particular use cases in detail in the coming slides. So the first case is automotive use case. So in general, the challenge of this particular challenge with the recycled polymers when we are injection molding is basically comes from the high melt flow resistance. So in order to reduce, there is a demand to reduce the melt flow resistance because with the particular additives in the recycled polymers, because of the high melt flow resistance, injection pressure will be increased, and therefore the energy usage will be increased in injection molding, and this also affects the quality and reproducibility of the molded parts. So at the moment, the texturing approaches are basically on the chemical etching, and this is basically a multi-step and hazardous process, which is also time consuming and requires frequent refurbishment. So in Syntex, with the laser surface texturing approach, these chemical steps, multiple chemical steps are replaced by the single step sustainable laser surface texturing by creating micro and nano textures that reduces the resistance to the melt flow as well as improve the mold lifetime. So the key performance indicators or key objectives for this case study are basically to reduce the injection molding pressure by 21% when we use the recycled polymer blends, and also achieve 100% texture transfer efficiency, and also replace the chemical etching steps with the single step hierarchical laser texturing. The additional functionalities are also sought, which are antimicrobial and anti-scratch from the Stellantis. And so in the next slides, I'll present what are the approaches we have taken to achieve this particular functionality. So in order to achieve the pressure drop functionality, which is to reduce the injection molding pressure, as you can see from the very first image here on the top, a spiral mold is designed by one of the partner IPC, and the spiral mold is textured with different configurations such as laser-induced periodic surface structures and hierarchical textures. And by measuring the pressure at different parts of the mold, the how much pressure has been injected into the how much pressure has been received by the mold has been calculated, and from there the pressure drop projection has been estimated. And the second functionality is anti-scratch and antimicrobial. In order to test these functionalities, flat molds are selected as shown in the figure below, and different textures such supplied by the Stellantis, which are basically the replica of chemical etching, has been manufactured by the laser surface texturing, and they are replicated onto the polymer molds. And different polymers are selected for this purpose, as shown in this particular table on the right side. Those are polycarbonate ABS blends, polypropellant, and polycarbonate again, with both virgin and recycled polymers. So these are some of the functionalities. In the first case, the antimicrobial functionality has been investigated with the different textures such as triangular laser-induced periodic surface structures and linear laser-induced periodic surface structures, and also hierarchical structures covered with both lips and without lips, as shown in these figures. So different polymers are tested with this particular textures, which are replicated into these polymers. And as you can see, both E. coli and SRS bacteria have been tested to understand the efficacy of these textures on antimicrobial properties. As you can see from this slide, not all the textures and not all the polymers have given a good result. From our investigation, what we understand is only two particular polymers with when we replicate with hierarchical texturing has given like more than 99% of antimicrobial efficiency from our investigation. This slide shows the anti-scratch functionalities on the textures replicated onto different polymers. Especially 3 different textures are selected as shown in the first 3 images. These textures are basically the replicas of chemical etching. So A9, F12, and H06 are nothing but quasi-random textures and random textures which can be fabricated by chemical etching. And the below plots show that the scratch resistance and mar resistance on the surfaces tested by Stellantis. And as you can see, not all the textures and not all the polymers have given rise to good performance. And for example, A9 and H06 textures have performed very well compared to the other textures, both in terms of scratch resistance and mar resistance. This particular slide shows the pressure drop reduction. The heat map shows that basically different texture configurations, right from triangular lips, DLC coated lips, and 3D hierarchical textures along with the DLC coating, and also together with different polymers, how they have performed with respect to pressure drop measurement. Again, not all the polymers have been, and not all the polymers and not all the texture configurations have given rise to positive reduction in pressure drop. As you can see, only few of the most of the textures have given rise to reduction in the pressure drop, and especially when we selected 3D hierarchical textures like lotus leaf, that has given rise to minimum of 14 in the standard conditions, and 21% of pressure reduction has been achieved with the heat and cool technology. Here, the heat and cool technology is when basically when we inject the polymer, the mold will be heated, and when we are taking out the polymer, the mold will be cooled down by the heat regulation system inside the polymer mold. So finally, at the coupon level, after the coupon level testing is done, the same textures are produced on the actual demonstrator as shown in this particular slide. So the CAD of the mold is shown here. The mold before machining is also shown here, and this is where the mold portion in the SYNTECS machine and started machined, and finally the mold were textured and it was ready for coating with the DLC before injection molding trials.